In this video, we're going to learn how to calculate the energy of a photon. We're going to use this formula, E equals h nu. The h is new to you. It is Planck's constant. The digit for that is 6.62 times 10 to the negative 34 joules times seconds. And the E over here stands for energy, and it is measured in joules. So just like speed of light, you will not solve for Planck's constant, but you can solve for energy. And this one is just like in the speed of light, it's the nu or the frequency. So example number 1 says calculate the energy of a quantum of radiant energy with a frequency of 5 times 10 to the 11th cycles per second. And here are the three variables, E, H, and nu. It says calculate the energy, so I'm going to put a question mark there for E. The h is lowercase, 6.626 times 10 to the negative 34 joules times seconds. And we have a frequency of, so that is the nu, 5.00 times 10 to 11 cycles per second. After that, I'm going to write the formula. I'm going to take a look. It is solving for E. I'm looking for E, so I'm in the correct format. I don't have to rearrange anything. I'm going to take Planck's constant, 6.626 times 10 to the negative 34 joules times seconds times 5.00 times 10 to the 11 cycles per second. The seconds are cancelable because this one is a numerator and this one is a denominator. And then in my calculator, when I multiply these two numbers, I get 3.31 times 10 to the negative 22. J or joules is not canceled out, so I'll carry that. And the energy for a quantum for a frequency of 5 times 10 to the 11 cycles per second would equal 3.31 times 10 to the negative 22 joules. Example number 2 is very similar. It says give the energy of a photon of this light in joules traveling in a wave with a frequency of 3.0 times 10 to the 15 cycles per second. So I'm going to take those three variables again and list them off to the side. It says give the energy, so I'm calculating energy. I always have Planck's constant. It is a given. I'm never going to solve for it. So I'm just going to write that in my variable list. And my frequency is 3.0 times 10 to the 15 cycles per second. Formula, again, I'm going to write it. E equals hv, or Planck's constant nu. It's set up to solve for E, or energy, and I'm looking for that, so I don't have to do any additional work. I'm going to plug in the numbers. And again, I can cancel seconds because this one is a numerator and that one is a denominator. I can only have two significant figures in the coefficient because of 3.0. My calculator gives me quite a lot more, but I'm going to round it to 2.0 times 10, and the exponent is negative 18. Joules is not canceled, so I'm going to carry that into my answer. And here is the energy of a photon if the light has a frequency of 3 times 10 to the 15 cycles per second.